Do you want to get started on a path of in-depth football analysis? Well, this video is for you. Welcome to Sports Betting Truth, where it is my goal to give you actual sports betting advice without the touting, shilling, hype, or false promises. Today is going to be a video for people who are looking to get more in-depth with football analysis. Now, in my opinion, when it comes to football, it's the absolute worst sport when it comes to being able to analyze things from the box score, because there's just so much in the box score that you cannot learn from a football game compared to other sports. There is so much missing. So in order to really get deeper into football analysis, you have to get a little bit creative and use some stats that aren't going to be right there for you to use. There's a couple different ways you can go about this. You can go really deep and use play-by-play data, or you can do what we're going to do today and use drive level data, which I mined from play-by-play data. Now, the main stat you can derive from drive level data is drive efficiency, the measure of how well a team puts the ball in the end zone based on their starting field position. You're measuring how many points were scored on the drive minus the expected points for the drive based on the starting field position. Every yard line on the football field has an expected point value. When the drive starts on that yard line, how many points can be expected? So let's jump into this. So I have 3 Excel files. This is the first one. This is the play-by-play master file. Now, there's some good people on the internet that put together some amazing files of play-by-play data. This is for the NFL. So what we're looking at here is a master database for the 2018 season of every single play. Every single play is in this file. Not only that, but there are 256 different columns. It goes all the way to IV. This is a dream for a person like me, and it should be a dream for sports bettors. All this amazing data in a table, and the sky is the limit. If there was a file like this for college football, I would kill for that, but it doesn't really exist in this capacity. But the NFL is good too. Now, a lot of what we do when it comes to advanced analysis of sports, I would say a majority of our time is occupied mining the data and cleaning it up, because we have all this data right here, which is great, but we got to clean it up. We got to format it. That honestly is a majority of what we do, is cleaning up data. That's really the biggest limitation when it comes to sports analysis, is data. You can only do as much as the data you have. So we have all this amazing data right here. Now we just got to clean it up. So I made some macros to help extract drive level data out of this play-by-play master file. And this is the end result right here. The game ID, the drive number, the offense, the defense, the starting yard line for the drive, the result of the drive, how many seconds elapsed on the drive, and if the offense for the drive was the home team or the away team. That's 8 columns of data right there. It doesn't seem like a lot, but there is a ton that you can extract just from those 8 things alone. And I'll show you. So in order to extract drive level data from the play-by-play file, I'll attach the macros and a link to all these play-by-play files in the description. But I run 2 macros. The first macro I run is to determine when the drive starts, and it'll put a start in the row where the drive starts. And then the other macro determine where the drive ends. And once you know the start point and the end point for every drive, then you can extract the drive level data. Now, if I put a filter right here, I can show you exactly what all the drive results are. We got downs, field goal made, fumble, half means end of half, interception, missed field goal, punt, safety, or touchdown. Those are going to be all your options for how drives end. So what I did is I added a column called points. Now, points is how many points are scored on the drive, if any. 3 for field goals, and I just use 7 for touchdowns. I know touchdown is 6 points, but 7 is the average, right? So from here, I made a pivot table on this tab. So this column right here represents the starting yard line for the drive. This column right here represents how many times over the past 5 years the ball started on that drive. So only 13 times in the past 5 years has a ball started 1 yard from the goal line. And all 13 times it ended in a touchdown, because the average is 7. But the most common ones are obviously going to be the touchback yard lines, 75 yards from the end zone and 80. And so when the ball starts on the team's own 20-yard line, an average of 1.618 points were scored on those 3,879 drives. So if you do this for every yard line, you can generate an expectation. And here's the scatter plot right here. But as you can see, as you get closer to the end zone, it curves upwards. So this red fit line does not fit very well really inside the 20. It needs to curve upwards. And that's when you use a polynomial regression. So to do a polynomial regression, all I have to do is right-click on the trend line, format trend line, and click polynomial. I did a 5th order one because if you mess with the orders, you're looking for the best fit. And I think 6 might be a little bit too extreme, so I did a 5 order one. Now, you can display the equation on the chart, but I'm going to warn you, there's a bug in Excel to where this equation is wrong. But don't worry, there's plenty of free websites where you can copy and paste your data and it'll give you an actual accurate equation that you can use. So with this polynomial distribution, we know exactly how many points can be expected on every yard line that has an accurate line fit. And from there, on our No Kneels tab, we can create an expectation column, which is just the equation. I'm going to let you see the equation right here. If you want to pause it, go ahead and pause it. But here's the equation. Our x variable is just a starting yard line, and this calculates the expectation for every yard line all the way down. Now, another thing we can do is a results grid. We can chart the result, not just score, but the result of what happened on every yard line as well. I already pointed out how every time the ball starts 1 yard from the end zone, it's 13 for 13, perfect 100% for touchdowns. But going down to the most common yard line, 80, we can track how many times each occurrence happened. And then we can convert that into percentages. So 18.1% of the time, a touchdown was scored, 11.7% a field goal was made, 0.1% a safety, 13.2% of the time the ball is turned over, and 57% of the time something else happened, whether it be a punt, downs, end of half, whatever. So knowing that, we can make more polynomial graphs on this tab for touchdowns, field goals, safeties, and turnovers, and make more expectations out of that based on starting field position. So we can go back to our No Kneels tab, and now we have all these expectations as well instead of just points. So moving on, so this is my drive efficiency file, and this is for the 2018 season. So we're going to analyze this data even further. So what we do here is we've already seen these, right? And here's the actual drive result, right? So now we have all these actuals versus expectation. So the first thing we're going to do is what I call drive efficiency. It's a common stat in football, but not a lot of people know about it. So as I pointed out earlier, drive efficiency is this right here. How many points were scored on the drive minus how many were expected. So if 0 points were scored on the drive and 1.76 points were expected, then the drive efficiency for that drive was minus 1.76. In this case, 2.16 was expected, but 7 was scored, so the drive efficiency was 4.84. It's a great stat for measuring how well a team puts a ball in the end zone based on what's expected of the average team. And then you just sum this all up for the entire season, and you can get a season-long drive efficiency. So that's what this tab is. It is the average, unadjusted drive efficiency for all 32 teams for the 2018 season. No surprise, the Chiefs are at the top. They had the best offense in the NFL. The Cardinals at the very bottom. They had the worst offense in the NFL. And our average team, the Detroit Lions, at 0. But you got to remember, this is being measured off the past 5 years of data, but scoring has been up over the past few years. So that's why this number is not at 0, because it's more offensive friendly, but we're still using 5-year-old data to measure this. So that's why it's not 0. You can also do the same for defense. In this case, smaller is better. So the Bears had the best drive efficiency last year at minus 0.48. The Oakland Raiders, the worst, at 0.7. Our average team is going to be the Colts, almost at 0. So how well does the team prevent the other team from putting the ball in the end zone based on starting field position? We can also calculate the same thing, but instead of points, results of drive end types. So that's what this is right here. So the Chiefs did the best at scoring touchdowns versus expectation. The Jaguars the worst. The Ravens did the best at scoring field goals versus expectations. The Cardinals the worst. The Buccaneers were the worst at turning the ball over. The Packers were the best. And then defense, the Bears were the best at preventing touchdowns. The Raiders were the worst. The Bears were also the best at creating turnovers. The 49ers were the worst. So you can use this data in a lot of different ways. And then we can also calculate home advantages based on these things. So if the league average is 0.132, the away teams is only 0.03, the home team 0.227. So that's plus or minus 0.09 based on home and away. That's your home advantage for drive efficiency. We'll be using this later. As well as touchdowns. If 0.021 is the league average, 0.009 for away, 0.032 for home. Turnovers is kind of low, but you can utilize home advantages for your calculations later on. Don't worry, I'm going to show you how you can apply this for meaningful analysis. There's also 2 other things you can measure here. Average starting field position for offense, and the average number of seconds each offensive drive took for each team. Time of possession. So the Saints were the best team in the NFL in terms of average starting field position. And remember, that's not just an offensive stat. That's also a defensive stat, because you can have better average starting field position if your defense does a good job at turning the ball over. And average number of seconds. Now in college, this is probably going to be more meaningful of a stat because you have a lot of teams that like to play fast pace or slow pace, but in the NFL, everyone's kind of the same. So this is going to be more of a measure of how good your offense really is. The Cardinals, the lowest time of possession in the league, also the worst offense. And you can do the same for defense. In this case, a higher number is better for your defense. So the Chiefs were the best team in the league in terms of average opponent starting field position. And which team did the best job at getting their opponents off the field? The Bears. So that's just a rundown of the pivot tables I've created from this data. So now we can start to move on to the adjustment phase. All right, you knew I was going to do stat adjustments at some point. We are adjusting stats of drive efficiencies based on the strength of the opponent. The Falcons' season-long offensive drive efficiency was 0.6. The Eagles' season-long defensive drive efficiency was 0.11. And the national efficiency was 0.13. So the Eagles just slightly better than the national average, but the Falcons way better than the national average. So for this drive that started 75 yards away from the end zone for the Falcons, they could be expected to score 1.76 points. They did not score, so that's a drive efficiency for that drive of minus 1.76. So we're going to take that number, minus 1.76. So first, we're going to calculate both teams' differentiation from the national average. Falcons plus 0.47. Eagles minus 0.02. So to adjust the offensive drive efficiency for the Falcons, we are going to take that drive efficiency plus the difference between these two numbers right here, which is minus 0.02. We take minus 0.02 and add it to the minus 1.76, and we get minus 1.74, but we're not done. We also have to remember home advantage. So remember the home advantage of minus 0.09 for away teams and 0.1 for home teams? Well, we're going to subtract this from the minus 1.74, which gives us minus 1.64, which is the overall adjusted offensive drive efficiency for that drive based on the strength of the Eagles' defense and compensating for the away disadvantage. Same for defense. So for defense, we take minus 1.76, and we subtract the difference between this number and this number, which is 0.47, which gives us minus 2.23, but we also got to add the home advantage to that to give us minus 2.13 to compensate for the Eagles playing at home. Remember, the point of adjusted stats is to normalize everything, to take home advantages out of the equation and factor in the strength of the opponent to give you a normalized neutral stat. Again, the whole point of an adjusted stat is to measure how the team would perform on a neutral field against the average team. So now that we've made all the game adjustments, we can do the same thing. We can sum them all up in a pivot table to get our adjusted season stats. And that's what this is right here. So this column right here is the raw. This column right here is the adjusted for offense and defense. So let's see if anything changed. So the Chiefs' offensive adjusted efficiency actually went up, meaning they probably played stronger defenses than the league average team. And for defense, let's see if anything changed. The Ravens overtook the Bears, meaning the Ravens played better offenses than the Bears did, so they were able to take them over. But we're not done yet. We're going to adjust these stats and adjust them again for round 2 of adjustments. Same thing. Only this time, this column right here is not the raw stat like this column is right here, but the adjusted stat. And it's the same exact process repeated just over here. I'm not going to go through it again. And now we have round 2 of adjustments. So it's an adjustment of the adjustment to make the adjustment more accurate. Now you can do this as many times as you want, but for this I'm just going to do it twice. In pro sports, you can get away with doing it a less number of times. In college, you'd probably want to do it a few more times. So now we have a new column, adjusted X2 efficiency. So let's see who the top team is here. Chiefs, even better. Now, not only are the Chiefs the top team, but they also had the biggest leap in terms of change from raw efficiency. The biggest decline was right here, the Bears, who went from 0.155 all the way down to 0.086. On the defensive side, the Bears overtook the Ravens again for the top defense. Remember, smaller is better. So the biggest improvement came right here, the Panthers, going from 0.414 to 0.361. The biggest decline, or should we say increase in this case, which is bad, the Colts, going from a negative raw efficiency to a positive one. So that's not good. They must have played some really weak offenses. So now the part you've all been waiting for. How can you use this data to predict? Well, I'll show you an easy way, a simple way to predict using just this data that we've learned. This is a simple way. You can easily build upon this and make an even more complex predictor, but for the sake of simplicity, this is what I'm going to show you. So let's have a hypothetical matchup from 2018. Let's say our away team is the Cowboys and our home team is going to be the Chiefs. So we have our season stats right here, the adjusted offensive drive efficiency, the adjusted defensive drive efficiency, the average offensive starting field position, the average defensive starting field position, the offensive pace, and the defensive pace. Now these four stats right here, I did not adjust for this example, but you could easily adjust those stats just like you adjusted the drive efficiencies to make them more accurate. And now this section right here measures the difference between the team stats and the national average, which are these three right here. So the Cowboys have a slightly worse offense than the national average, a slightly better defense than the national average. The Chiefs have a much better offense than the national average, but a much worse defense than the national average. Now that we know versus the national average, we can calculate expectation. Now, if you've watched my videos, you know what expectation is. It's pretty easy to calculate. All you do is take the national average. So for offensive drive efficiency, that's going to be 0.13 plus these two numbers, plus the Cowboys' offensive drive efficiency versus the national average, and the Chiefs' defensive drive efficiency versus the national average. So it's 0.13 plus 0.63 to get 0.76, which is the expected drive efficiency for the Cowboys in this game. And then you do the same thing for the Chiefs, 0.13 plus 1.22 plus minus 0.07, so 0.13 plus 1.15, which equals 1.28. So the Chiefs, 1.28 offensive drive efficiency for the game. And then the defense is just going to be the inverse of each other's offensive drive efficiency. And then you can do the same thing for field position, and you can do the same thing for pace. This number right here represents the average of these two numbers, so the average pace. And from there you can calculate estimated number of possessions for the game. So if the teams average about 3 minutes per drive, you divide that by 60 minutes to get 20.02, basically 20. 3,600 seconds divided by this number right here. So we can expect each team to have about 10 possessions for the game. And once we know that, we can calculate the expected points based on average starting field position. If the Cowboys are going to be expected to start every drive from about the 25-yard line, we can use our polynomial equation from earlier, which is right here, to calculate their expected points for each average drive. So if the Cowboys' average drive is going to start from the 25, we can expect them to score about 1.75 points per drive. Same for the Chiefs, but they're starting from about 32. They're going to be expected to score 1.96. And then all you do is add. So for the Cowboys, we're going to start with their offensive drive efficiency plus 1.75. That gives us 2.51. But we also need to factor in home advantage. We need to subtract minus 0.09 from there to get an expected points per drive for the Cowboys of 2.42. 0.76 plus 1.75 minus 0.09 gives us the expected points per drive for the Cowboys at 2.42. Same for the Chiefs, 1.96 plus 1.28 plus 0.09, which gives us 3.33 expected points for the Chiefs on every drive. And then we have our projection. All right, so this is easy. It's just expected number of possessions times expected points per drive. 24.21 for the Cowboys, 33.38 for the Chiefs, a margin of 9.17. So if you're using this to make a spread, the Chiefs would be favored by about 9 in the game. If you wanted to bet using this information, you just compare that number to the spread and see if you have any value. Now, I'm not saying this is simple because this is actually a pretty advanced way to calculate a prediction for an NFL game, but it's still pretty simple. You could build upon this and add more elements to it. We went from these 8 columns to being able to predict NFL games just from those 8 columns. That's pretty crazy, but that's the power of drive level data and drive efficiency. You cannot gather that from a box score, but that's the overall basics of drive efficiency, which I think is the most powerful advanced stat in football analysis that you can get from drive level data. And like I said, you can go even deeper with play-by-play level data. It's going to take more work, but you can extract a lot out of play-by-play level data. Ideally, what you do is you combine your drive level data with your play-by-play level data and use both of them in synergy with each other to make the ultimate predictions. Now, when it comes to play-by-play level data, that's another video for another time, but one of the best stats you can extract from that is success rate. So I hope you can use this lesson on advanced football analysis to help craft an overall better strategy to help you predict games. There's a lot you can do with football, but that's the problem with football. The best stuff is outside of the box score, and you gotta mine it. Well, that wraps it up today for Sports Betting Truth. I hope you learned a lot today. If you liked what this video had to show you, go ahead and hit that subscribe button and the like button. Stay tuned for more videos. I got a lot more coming, especially as we approach football season. Until next time, this is Sports Betting Truth, signing off.